Hi, my name is Obed from Embedded Systems Academy. Welcome to this very first lecture in the course Introduction to Embedded Systems using Arduino. In this lecture, we shall talk about Introduction to Embedded Systems. At the end of this lesson, you shall have understood what embedded systems are, what consists of embedded systems, and why they are important to us today. So welcome to the class and enjoy. We're going to talk about embedded systems, and this is actually a theoretical introduction to embedded systems. So we shall define a few things and be able to understand what embedded systems are. So when you think of an embedded system, you may ask yourself, what is an embedded system? So first, we may start with actually understanding the word embedded system. So first we may say, let's define the word system. And a system, according to Wikipedia, is defined as a system is a group of interacting or interrelated entities that form a unified whole. Or as well, you may find this definition somewhere, and it says it's a way of working, organizing, or doing some or many tasks which are performed in a fixed plan or program or a set of rules. So that is briefly about a system. So it means there are two or more components in a system, and these things are working together in a fixed plan or a program following a certain pattern. So this will be able to help us understand what an embedded systems are. So an embedded systems, according to Wikipedia, still is a computer system, which is a combination of a computer processor, computer memory, and input-output peripheral devices that have a dedicated function within a large mechanical or electrical system. So here we have a large system, but again, there are those dedicated functions performed by an embedded system. So the definition that I like most is this one, that is actually an embedded system is a system that has software and hardware. The system is dedicated to either an application or a specific part of an application. And finally, someone defined this as is an electromechanical system designed to perform a specific function in a combination of both hardware and firmware. Of course, firmware can also be called as software in this case. So an embedded system is simply a combination of hardware and software that is doing a specific function, either in an application or part of an application. So that is an embedded system. So what is the difference between an embedded system and a general computing system? So here are the differences. So in a general computing system, the hardware is generic, and as well the operating system is actually a general purpose operating system. For an embedded system, we have a special purpose hardware and also an embedded OS or operating system. In general computing systems, the applications are alterable, they can be changed somehow, modified on the system, while in embedded system, the system comes pre-programmed and that is not alterable by the end user. Of course, lately we have a way of altering, but essentially an embedded system has a pre-programmed and an alterable system. For a general computing system, performance is the key factor. They say faster is better. But for embedded systems, application-specific requirements are considered, and mostly it's power and memory. And lastly, for a general computing systems, the response time is not time critical. While in embedded systems, response time is a highly critical factor in most applications. You want to perform a certain task in a very critical time ratio, a very specific time factor that is considered in embedded systems. So that's the difference between a general computer system and an embedded system. So when did we start having embedded systems? Just maybe a short history about embedded system is when we consider one of the very first recognizable modern embedded systems, and this was the Apollo guidance computer. And it was actually the first modern system to collect and provide flight information to automatically control and all of the navigation functions of the Apollo spacecraft. This is one of the greatest milestones in embedded systems. It was developed in the early 1960s for the Apollo program by the MIT Instrumentation Lab. This was actually led by Charles Starkdraber in this MIT Instrumentation Lab. You will understand that the man on the moon was a huge milestone in the history of technology and of the Cold War, made possible entirely by the MIT ingenuity. So embedded systems have come a long way from the 1960s up to the current date. We are seeing improvements and advancement in embedded systems. Maybe you will go out and there and do a further research, know exactly when did we have the very first embedded system and where we are at the moment. And we shall be talking about those generations briefly in this class. So we want to talk about the classification of embedded system. We can classify embedded system using 4 factors. 1, based on generations. 2, based on the triggering event. Number 3, based on the deterministic behavior of the system. And number 4, based on the complexity and performance of the system. So these are the 4 ways we shall classify embedded system. Now, based on generation, there are 4 generations of embedded systems. We have the first, second, third, and fourth generations. So the first generations actually is composed of 4-bit or 8-bit microcontrollers or microprocessors. An example is 8085. These are a 4-bit or 8-bit processor that is normally programmed using assembly language. And in this generation, the hardware is simple and as well as the firmware. An example is of this kind of embedded systems as are digital keypads, stepper motor control units. And the second generation of embedded systems has 8-bit or 16-bit microcontrollers or microprocessors. Now here we have complex hardware and powerful instruction set than the first generation. Examples of this kind of embedded systems is data acquisition systems such as SCADA. And then the third generation is composed of 16-bit to 32-bit embedded systems or microcontrollers, and they are more applicable in digital signal processors and ASICs, or we call it because they have complex and powerful instruction set with instruction pipelining. Of course, maybe I give you this as an assignment to find out what is pipelining. They also have dedicated embedded real-time operating systems or general purpose operating systems. An example is robotics. When you see robotics, those are third generation embedded systems. Now, fourth generation embedded systems are composed of systems on chip. These are reconfigurable processors, and also there are multi-core processors. They actually have a high performance and tight integrations, and of course they include miniaturization. This is where we have very small systems or chips that can perform complex tasks. An example is your smartphone. Every day we are seeing smaller and smaller phones doing great tasks. In fact, some of them can do better than even your laptop and even PC. So our question will be, what is next? Of course, this is complex. Maybe we wait and see what kind of things are coming. Of course, they are more complex, more cheaper, and let's just see and see, wait and see what is coming next. Now, based on complexity and performance, embedded systems can be classified to three. We have small scale, medium scale, and large scale. In small scale, you have simple application, and these ones are no time critical. They do not have an operating system, and mostly they use low cost 8-bit and 4-bit microcontrollers. An example is an electronic toy. Those are very small and basic embedded systems. And then medium scale are those who are slightly complex in hardware and software. They use general purpose operating systems or real-time operating systems. These employ low-cost 16-bit or 32-bit microcontrollers or processors. The large-scale embedded systems are highly complex in both hardware and software. They're mostly applicable in very mission-critical tasks that demand high performance. And these ones use 32 to 64-bit processors. They even actually use high performance real-time operating systems. An example is actually systems that do decoding and encoding of media, audio, and such tasks. So based on complexity and performance, we have those three kinds of embedded systems. Now, based on the triggering event, we have reactive systems. They are embedded systems which are triggered when an event occurs, and there are those that are triggered based on time. For example, we may have when a temperature of a house gets to a certain point, then the AC is turned on. That's an event triggered system. For time triggered systems is for example an alarm system where at a particular time then an alert system is triggered. Then that is actually a time triggered reactive system. Now, based on deterministic behavior, you have real-time systems as either soft or hard. Now, maybe this could be an assignment to us and to you to find out what this exactly means. Which kind of systems are these, soft and hard? So, why do we apply embedded systems? Actually, embedded systems are everywhere and all over. From actually what you're using at the moment. So these are the major application areas of embedded systems. In consumer electronics, we have a variety of devices that are used that are embedded systems. For example, a camera, the digital cameras. These are embedded systems in application. We have household applications. We have your TV, DVD players, washing machines, fridge, microwaves, and etc. These are all embedded systems. In home automation and security systems, such as air conditioners, sprinklers, intruder alarm detections, fire alarms, all these are embedded systems. Automotive systems, you have engine control, ignition control, automatic navigation systems. All these are examples of embedded systems that we interact with every day. It's also applied in telecom, in your phone, in the routers. All those are embedded systems. They're also in the computer peripherals, a mouse, a printer, a scanner. Those are still embedded systems. And actually, we find them everywhere in our day-to-day experiences. They are all over, and we can call them our sacred friends. They are all over. We walk with them, we interact with them each moment, each day, because they are part of us in this era of technology. So those are actually some of the major application areas. So what is the purpose of embedded systems? Now, there are 5 purposes of embedded systems and of a typical embedded system. One, they are used in data collection, storage, and representation. Of course, you have 2 kinds of data. You have analog and digital. And this data can be collected, transmitted, processed, and displayed by an embedded system. That is one task of an embedded system, to collect data. Again, after the collection of data, an embedded system also does signal processing or data processing. Of course, data collected without processing is useless. So this data, once collected, is processed by an embedded system. So that's another purpose of an embedded system. Another very important purpose of embedded system is control. Now let's look, for example, a room where you have an air conditioner. We may have a sensors that detect the level of temperature in that room, and based on a threshold, the air conditioner is then turned on. In that case, the purpose of an embedded system will be to control the parameters of the house. And so most of the embedded systems perform control functions. And then another purpose is data communication. We have 2 kinds of data communication. We have wired and wireless. Of course, we have very many protocols of wired and wireless communication protocols. We may have USB as a wired communication protocol, Wi-Fi as wireless, Zigbee, LoRa, and many others. So embedded system can be applied in data communications. Of course, they are used in monitoring. We are actually living in a world of sensors. We have the monitoring of every parameter in the environment, may it be temperature, humidity, sunlight. All these things can be monitored using embedded systems, and this is one of the work of embedded systems. And finally, we have application-specific user interfaces. When you walk into an ATM, you will see a screen, you see a keypad, and all that is an application-specific user interface for a banking system. And so that is one of the purposes of embedded systems. And so what are the components of a typical embedded system? So we have this system. Remember, we defined an embedded system as like a collection of entities that are doing a specific task. So what are these components of an embedded system? So we have these components in an embedded system. One, any embedded system has a power supply. They cannot run without a power supply. And then they have the processor. This is like the brain of the system. We have memory. We have timers and counters. We have communication ports. We have inputs and output ports. And then in some systems we have application-specific circuits. These are peripherals to the system, just electronic parts of the system. So graphically, you can see this is like the core of the embedded system. We have the processor, memory, timers, interrupt controllers, parallel ports. This is now where we have the inputs and outputs, communication ports as well. So for this core, we have input devices that are interfaced to this core, and then the input of course provides an output after the processing of the data. Then we have of course power to the system, and also we have a system application specific circuit to this system. So generally that is the composition of an embedded system. So throughout this course we shall be learning how to design a simple application using embedded systems. In our case, we shall be using the platform Arduino to do all these things and be able to design simple embedded systems that can be able to solve specific problems.